Today we're going to be looking at a problem that involves proportional reasoning. This problem uses ratios, rates, and represents a directly proportional relationship. We're going to make comparisons today using unit rates. So let's begin by looking at the question. The D'Souza family is going on a trip to Prince Edward Island and back. It is 1,600 kilometers from home to PEI. Determine the total cost of the gas for the D'Souza family's trip to PEI and back if the cost of gas is 128 cents per liter and the car uses 9.8 liters per 100 kilometers. Show your work. So let's begin by underlining some important information that we're told in this question. Do we know how far the D'Souza family travels? Well, we know that it's 1,600 kilometers from home to PEI, but they're going there and back, so let's not forget that. Do we know how much gas costs? Yes, it's 128 cents per liter. So for every 1 liter that the car uses, they have to pay 128 cents. Or, how do we write this as a dollar amount? That's right, $1.28 per liter. Well, do we know how many liters the car uses? It uses 9.8 liters for every 100 kilometers it travels. But the car travels a total of 1,600 kilometers one way. So what do we need to find here? Well, they're asking us to find the total cost of gas. So where do we begin? Well, let's start by writing down some rates that we know, since today we're going to be solving this question using unit rate. Do you remember what rate means? Rate is a certain quantity that's considered in relation to another quantity. So what are the two quantities here that are related to one another? Do we have more than one rate in this question? Well, to begin with, we're looking at the cost of gas, so the cost in dollars, for every liter. What is that? And what is that rate? It is $1.28 per 1 liter. This is a unit rate because the second term is 1, so we know the cost of gas for every 1 liter. Do we have another relationship here? Yes, we're also looking at the amount of gas used in liters in relation to the distance that the car travels in kilometers. So what is that rate? It is 9.8 liters for every 100 kilometers. Do we know what this is as a unit rate? Do we know how much gas the car uses for every 1 kilometer? No, but that's what we're going to find today. Why do you think it would be helpful to determine how many liters the car uses in 1 kilometer? Well, do we know the total number of kilometers that the D'Souza family travels? We do know that they travel 1,600 kilometers for one way. To come back, they also travel 1,600 kilometers. So how would we find the total number of kilometers that they're traveling? That's right, we would add 1,600 plus 1,600. Altogether, they travel 3,200 kilometers on their trip. If we know how many liters that the car uses for every 1 kilometer, how do you think this will help us to find out how many liters the car uses for 3,200 kilometers? Think about this. So how are we going to determine how much gas is used for every 1 kilometer? We know the rate for every 100 kilometers, but we need to know the unit rate, the amount for every 1 kilometer. Well, how do you reduce 100 to 1? Think about it. Anytime you divide a number by itself, it reduces to 1. So 100 divided by 100 is equal to 1. Well, if the second term was being divided by 100, what do you think you need to do to the first term? That's right, we would also need to divide this by 100. 9.8 divided by 100 gives us 0.098. Therefore, the car uses 0.098 liters for every 1 kilometer. This is a unit rate because it tells us the amount for every 1 kilometer traveled. To find the unit rate, what we actually did was we took the total number of liters of gas that the car uses and we divided it by the total number of kilometers traveled, which was 100. 9.8 divided by 100 is equal to 0.098. Well, now we know how many liters of gas the car uses for every 1 kilometer. How can we use this information to help us answer the question? Do you remember how many kilometers the D'Souza family travels? Well, we know that they travel 1,600 kilometers for one way, and we figured out earlier that for 2 ways, there and back, they travel a total of 3,200 kilometers. Well, if the car uses 0.098 liters for 1 kilometer, how can we find out how many liters it uses for 3,200 kilometers? As the distance increases, the amount of liters must also increase. To show an increase, we're going to multiply 0.098 times 3,200, since we're increasing our kilometers by 3,200. So this is equal to 313.6. 313.6 what? 313.6 liters for every 3,200 kilometers. Therefore, the car uses 313.6 liters of gas for this trip. But what was the question asking us? The question didn't ask us to determine the amount of gas used. The question asked us to determine the total cost that the gas will be. So what information will help us solve this part of the question? Well, if you remember earlier, we circled 128 cents per liter. So we know the unit rate of cost, which is $1.28 for every 1 liter of gas used. So now what? Well, if we know the total cost for every 1 liter, and we know the total amount of liters that this car needs for the trip, can we figure out the missing cost? What do you do to the number 1 to increase it to 313.6? Well, because this is proportional, we know that it has to be related by multiplication or division. So 1 times 313.6 will give us 313.6. What do you think we need to do to the first term? Well, if we multiplied the second term by 313.6, we need to multiply the first term by 313.6 as well. 1.28 multiplied by 313.6 gives us 401.408. But what is this rounded to the nearest cent? It's either going to be 40 cents or 41 cents. Well, if we look at the number next to 0, the number is 8. That's a number that's greater than 5. So if the number is 5 or greater, we always round up. So the total cost for 313.6 liters would be $401.41. Therefore, we just found that the total cost of gas for the D'Souza family's trip is $401.41. And that's because they used 313.6 liters of gas and they traveled a total of 3,200 kilometers. We've just solved this problem using unit rate, but think about all the different ways you could have solved this problem. Check out our playlist to see different methods of solving this exact question.